So I'm out on my driveway last Saturday morning. Coffee's barely warm. And I watch my neighbor, good guy, decent family man, don't get me wrong, drag his old microwave to the curb like he's hauling out a dead animal. Just shoves it next to the recycling bin with his foot. Walks away. Done. Doesn't even look back. And I don't know. Something in my gut just twisted. Because I know what's inside that box. I've pulled these things apart with my own hands more times than I can count. And what's sitting in there, buried under the grease and the rust and the busted door latch, is a piece of raw industrial hardware that most people will never understand. Not because it's complicated, because nobody ever taught them to look. Now that same man, and I like the guy, I really do, he spent over $2,000 last spring on a brand new inverter generator. I watched the delivery truck pull up, saw the box, saw the logo, and look, it's a beautiful machine. Bluetooth connectivity, digital fuel gauge, automatic idle control, every bell and whistle you can think of. But here's the thing, every single one of those features runs on circuit boards thinner than a credit card. Microchips that will fry like bacon the second a serious electromagnetic event rolls through. Solar storm, infrastructure attack, cascading grid failure. Whatever you want to call the thing nobody in Washington wants to talk about, honestly. I mean, think about that for a second. $2,000. And it's basically a paperweight waiting to happen. And the thing he just threw away? The $30 microwave from 2011 with coffee stains on the handle? Inside that thing is a transformer built on a principle so old, so mechanically raw, so brutally simple that it answered to the same laws of physics before the internet existed, before transistors existed, before his grandfather's grandfather was born. So today, I'm going to open that box. I'm going to show you exactly what's inside. And I'm going to explain, in plain language, no engineering degree required, how that one component has been quietly repurposed by fabricators, off-grid builders, ranch mechanics, and field engineers into welders, battery charging rigs, shop tools, and emergency backup systems for decades, all from something America throws away by the millions every single year. But before I touch a single screw on that chassis, I need to tell you something that might save your life. And I'm not being dramatic here. I'm being very, very specific. Here's where most guys screw up. And I get it. I almost made this mistake myself early on. You see a dead microwave. You grab a screwdriver. You start pulling things apart like it's a toaster. And that right there is how you end up on the floor with your heart doing something it wasn't designed to do. I'm not the kind of guy who softens things up to keep people comfortable. Comfortable people are almost always the least prepared. So I'm just going to give it to you straight. Inside every single microwave oven ever manufactured, there is a high-voltage capacitor. Now it looks like nothing. Seriously, small metal cylinder, maybe the size of a beer can, bolted to the chassis. Your eyes would slide right past it. But that little cylinder stores electrical charge. And I don't mean a little static zap like shuffling across carpet in your socks. I mean genuine, dangerous, over 2,000-volt charge. The kind that can stop a grown man's heart. And here's the detail that gets people hurt every single time. That capacitor holds its charge long after the microwave has been unplugged. Days, sometimes weeks, sometimes longer depending on the unit, the humidity, the condition of the components. But the point is this, you unplug that microwave, you throw it in your truck, you drive it home, you let it sit in your garage for a month, and that capacitor might still be fully loaded, just sitting there, waiting, patient as a rattlesnake in tall grass. And if you reach inside that chassis with a bare hand and brush the wrong terminal, or worse, you grab it with a pair of cheap pliers that aren't insulated, that's not a learning experience. That's an ambulance ride. Guys have ended up in emergency rooms doing exactly this on their own workbenches. Not because they were dumb, because they rushed, because they figured something that was unplugged must be safe. It's not. Trust me on that one. So the absolute first thing you do, before anything else, before you even think about what's inside, is discharge that capacitor. You use an insulated screwdriver rated for high voltage. Real insulation, not the $3 bargain bin special with the cracked handle. A real tool. You carefully bridge the two terminals on the capacitor and let that stored energy dump through the screwdriver instead of through your body. Sometimes you'll hear a loud crack, a fat blue spark. Good. That means it's working. That's energy leaving the component safely. I do it twice, every single time. Because honestly, I've got things I still want to do with the rest of my life. Once that capacitor is dead, now you're working with honest materials. Copper, iron, steel. Stuff that makes sense in your hands. Stuff that doesn't surprise you. And now the real work starts. Let me walk you through the guts of this thing and tell you what matters and what doesn't. Because I'm not here to waste your Saturday. The magnetron, that's the component that actually makes the microwaves to heat your food. Fragile, specialized, vacuum tube. Serves one purpose and one purpose only. For what we're doing today, scrap, set it aside or toss it. The control panel, the touchpad, the little digital clock that was always wrong anyway. All consumer-grade electronics, designed to make reheating last night's pizza slightly more convenient. Worthless to us. Gone, the turntable motor, the interior light bulb, the door safety switches. Look, none of that is why I pull over when I see a microwave sitting on somebody's curb. The high-voltage diode, now that one I actually keep. I toss it in a parts bin. If you ever get into rectifier circuits or more advanced electrical projects, that diode has real value, and it costs you nothing. The capacitor itself, once it's safely discharged, also goes in the bin for potential use down the road. But you respect that thing every single time your hand gets near it, even when it's dead, especially when you think it's dead. I'm serious about that. But the reason I'm here right now, the reason I literally drove 3 miles last Saturday to grab my neighbor's so-called garbage before the trash truck got there, is one specific component sitting at the bottom of that chassis, the transformer. And honestly, the second you pull one out and feel the weight of it in your hands, you'll understand why I'm making this video. First thing you notice is how heavy it is. And I mean heavy, legitimately heavy. 4, 5, 6 pounds of iron and copper packed together, like it was built by somebody who still believed in overbuilding things. And you know what? Back when this component was designed, that's exactly what engineers did. They didn't shave material to save 12 cents per unit. They didn't cut corners to hit some quarterly earnings target. They built it to handle serious electrical load, day in, day out, for years. And you can feel that the second you pick it up. It's called a MOT, microwave oven transformer. Sounds boring, I know, but stay with me. And what makes it different from basically everything else inside modern consumer electronics is what it doesn't have. No software, no firmware, no Wi-Fi chip, no Bluetooth, no touchscreen, no app. No fragile circuit board waiting to fail the first time things get rough. What it does have is a core made of laminated steel plates stacked tight, wrapped in copper windings. Primary coil on one side, secondary on the other. Energy goes in through the primary. A magnetic field forms in the core. Energy comes out through the secondary, transformed, stepped up or stepped down, depending on the winding ratio. Electromagnetic induction. That's all it is. Michael Faraday figured this out in 1831. And I'll tell you something, the physics haven't changed since. Not one bit. Not in almost 200 years. And they're not going to change when the lights go out either. That's what you're holding when you pull this thing out of a dead microwave. Almost 2 centuries of proven brute force electrical engineering sitting in the palm of your hand. Pulled from a box your wife told you to throw away last month. And here's the part that really got me when I first figured this out. Everybody sees a dead microwave and thinks kitchen junk, broken appliance, landfill material. Nobody picks it up, turns it over, and thinks about the 4-pound voltage conversion machine bolted to the bottom of the chassis. But that's exactly what it is. I mean, really think about that. It's not a microwave part in any meaningful sense. It's a power tool that happens to be hiding inside a microwave shell. This transformer was designed to take ordinary 120-volt household current and crank it past 2,000 volts to feed the magnetron. That means the core, the windings, the iron, all of it was engineered to handle serious voltage conversion as a basic everyday function. That kind of capability doesn't just break, doesn't expire, doesn't care whether the grid is up or down. It's raw electrical infrastructure sitting inside a kitchen appliance that your neighbor just put on the curb for the garbage man. And that's basically the secret most people never figure out. It's right there. It's always been right there. They just never knew what they were looking at. Now let me tell you what people are actually doing with these things. Because this isn't theory. This isn't some YouTube animation with a robot voice. This is happening right now in garages and workshops across rural America. done by people who understand what they're holding. In its factory setup, a MOT steps household voltage way up, dangerously high, to power the magnetron. That configuration isn't directly useful for most off-grid or emergency stuff. Fine. But here's the thing about transformers that a lot of people don't really think about. They work in both directions. The physics is symmetrical. This thin secondary winding right here, this is what takes ordinary household current and steps it into that dangerous high voltage. But here's where it gets interesting. You replace that winding with heavy gauge copper cable, and the entire behavior of the transformer changes. Now, instead of stepping voltage up to lethal levels, you're stepping amperage way up while keeping the voltage low and controllable. And you know what that gives you? An arc welder. I'm serious. A real, functioning, strike-and-arc welder, built from a component that was literally headed for a landfill 2 hours ago. I've seen guys in Montana repair horse trailers with modified MOT welders, ranchers in Texas patching cattle gates out in the field. A mechanic in West Virginia I talked to last year, good guy, been doing this a while, told me he hadn't bought a consumer welding rod in 6 years because he runs 2 modified microwave transformers in his shop, and they handle everything he needs for light to medium steel work. 6 years. From garbage. I mean, think about that. And it goes well beyond welding, too. That same transformer principle, copper, iron, magnetic induction, is the foundation of battery charging systems, emergency power conversion setups, low-tech voltage regulators, and experimental off-grid builds that guys in the fabrication and salvage community have been quietly refining for years. No fanfare, no marketing, no asking anybody's permission. Now, here's something I want you to actually sit with for a second. And I mean, really think about it. The entire modern electrical grid, every power plant, every substation, every distribution node between here and wherever you're sitting right now, runs on transformers. Same basic principle, coils of wire around a magnetic core converting energy from one form to another. That's basically the spine of modern civilization right there. And a scaled-down, rugged, overbuilt version of that exact same technology is sitting inside a dead kitchen appliance that America treats like it's worthless. Every single day, thousands of these get tossed, hauled to the dump, crushed, buried in a landfill, while the same people throwing them away go online and spend hundreds of dollars on survival gadgets made of plastic and circuit boards that probably won't survive the first hard winter without a functioning power grid. And honestly, that's the part that really gets to me, because here's the thing that nobody in the survival industry really wants to say out loud. You can buy every piece of gear on the market, every freeze-dried food bucket, every water filter, every solar panel kit, every tactical bag and medical kit and fire starter and battery bank and shortwave radio. And look, I'm not mocking any of that. Some of it is genuinely useful, and I own plenty of it myself, but all of it is consumable. Every bit of it has a shelf life. The food gets eaten, filters clog, batteries degrade, solar panels crack, fuel goes stale, parts break, and there's nobody to order replacements from. And then the question gets real simple. Now what? The people who actually adapt, and I mean the ones who make it through extended disruptions, not the guys who lasted 2 weeks on stored supplies and then didn't know what to do. Those people share one thing in common. It's not the biggest bunker. It's not the most ammo. It's not even the most money. It's mechanical knowledge. They understand how stuff works, not in some abstract way, with their hands. They can look at a pile of discarded hardware and see usable components where everybody else sees junk. They understand voltage, amperage, resistance, induction. They know how to repurpose things, modify them, adapt, build functional systems from whatever's available. And the guy who can do that, repair broken equipment, charge batteries from a salvage transformer setup, weld metal back together, improvise electrical systems from analog components that don't need a functioning supply chain to work. That guy doesn't just survive, he becomes the guy everybody needs. Not because he's got the most stuff in his garage, because he solves problems nobody else in the room can figure out. When the lights go out and every piece of digital consumer tech goes quiet, he's the one who knows how to get something running again. With a workbench, not a credit card. That's what this dead microwave really represents when you think about it. Not trash. Not a broken appliance from the kitchen. A test. And most people fail it every single week without even realizing there was a question being asked. Now I want to be straight with you here, because I've got no patience for people who string you along just to keep you watching. Owning the transformer is step 1. Having a bin full of capacitors, diodes, copper wire, salvaged magnets, that's still just step 1. Those are raw materials. And raw materials sitting on a workbench without a clear build plan and proper safety knowledge aren't preparedness. They're just a pile of heavy metal and, honestly, a pretty good way to hurt yourself. I know this because I lived it. I'm not guessing here. Years ago, before I really understood what I was doing, I had a garage full of salvaged parts from every dead appliance I could get my hands on. Microwaves, old CRT televisions, washing machines, window AC units, power supplies from desktop computers. I tore everything apart. Had shelves full of transformers, capacitors, motor assemblies, spools of copper wire. And I remember standing there looking at all of it, knowing, just feeling it, that these parts held real capability. That there was something useful sitting in that pile if I could just figure out how to connect the dots. But I was guessing. And let me tell you, guessing with high voltage and heavy magnetic components isn't a hobby. It's a hospital trip that hasn't happened yet. What changed everything for me was getting my hands on real technical documentation. And I don't mean internet forums where everybody's arguing with each other about stuff they read somewhere else. I don't mean 15-minute YouTube videos that show you the what but never really explain the why. I'm talking about actual winding diagrams, component specifications, step-by-step modification procedures, safety protocols, and tested build processes for turning salvaged analog hardware into systems that actually work off-grid. The kind of practical knowledge that used to live in the heads of old-school electricians, radio operators, industrial repairmen, military field engineers. Guys who could fix anything with whatever they had on hand because that's what the job demanded. That's what their generation expected. Before everything became disposable. Before just replace it became the answer to every problem. I spent years collecting this stuff, organizing it, testing it in real conditions, documenting what works and what doesn't, so you don't have to learn the hard way like I did. Building a clear process that somebody with basic hand tools, and honestly, zero electrical background, can follow safely from start to finish. And I put all of it into one resource. I call it the Salvage Power Blueprint. It covers transformer modification, the exact rewinding process, wire gauges, turn ratios, safety procedures for converting a standard MOT into usable off-grid equipment, capacitor handling, component identification, improvised welding builds, battery charging configurations, analog voltage regulation, emergency power conversion, and the foundational electrical principles behind all of it explained in plain English so you actually understand what you're building and why it works. Not just blindly following steps hoping nothing goes wrong. No free energy nonsense. No fantasy physics. No promises that break the laws of thermodynamics. I'm not that guy. Just proven, practical, field-tested salvage engineering designed to turn you into the person who doesn't need the system to be working in order to work himself. And if that sounds like something you actually want, if you're honestly done being the guy who throws away capability every weekend and buys dependence instead, I left the full breakdown of the Salvage Power Blueprint in the first pinned comment below this video. The diagrams, the parts lists, the modification procedures, the safety protocols, the beginner builds, everything I use, everything I've personally tested, organized so you can start this week with nothing more than a dead microwave and a workbench. Don't be the guy sitting in a dark house 3 days into an outage staring at a pile of parts he doesn't know what to do with. That's not preparation. That's just theater with extra steps. Learn the systems now. Build the skills now. While the lights are still on and mistakes are still cheap, and your neighbor is still putting perfectly good hardware on the curb every Saturday morning like clockwork. Because when the grid goes sideways, and honestly, brother, we're a lot closer to that than most people really want to think about. The only people who aren't going to be scared are the ones who already know how to make things work with their own two hands. Anyway, I'll see you at the workbench.